So these are the answers to these problems. You should have picked u to be x to the fourth minus 1. The derivative is 4x cubed dx. We notice over here I only need an x squared dx, or an x cubed dx, so I need to put a 1/4 du will equal my x cubed dx. When I rewrite the integral, it becomes u to the fifth, and then I need just a 1/4 du. The u to the fifth comes from right here, and then my du comes from my x cubed dx. When I integrate this, I get 1/4 u to the sixth over 6 plus c. So my answer becomes 1 over 24. This is my u to the sixth plus c. Remember, u was x to the fourth minus 1. Second problem. In this problem, we would make the u be 1 minus 3x squared. Du would be equal to negative 6x dx. I notice I only need an x dx, so I will write a 1/6 negative 1/6 du equals my x dx. When I rewrite the integral, it becomes u to the 1/2, or the square root of u. X dx is taken care of with the negative 1/6 du. When I integrate, I get negative 1/6. U to the 3/2 over 3/2 becomes the reciprocal 2/3 out front, plus c. So my answer would end up being negative 2 over 18, or negative 1/9. U to the 3/2 plus c. U again was 1 minus 3x squared. Problem number 3. U would equal 4x plus 3. Du would equal 4 dx. I only need a dx, so I know I'm going to have to move my 1 or my 4 over to the other side and make it 1/4. When I rewrite the integral, it becomes u to the negative 1/2. That's what's on the bottom here. I only need a dx, so I need a 1/4 du. This becomes 1/4 u to the 1/2 over 1/2 makes a reciprocal out front with 2 over 1. That would become 1/2 square root of u plus c. Square root of u is 4x plus 3. Those are the answers to the first 3 problems for day 1. For day 2, the first problem we look at here, if you try to make a u statement, it will not work out. So what you need to do is you need to simply FOIL this so that it is a term plus a term plus a term. First times first gives you x to the fourth. Outer times outer gives you x squared over x squared, which is a 1. Inner times inner gives you x squared over x squared, which is 1. And then last times last gives you 1 over x to the fourth. So you can rewrite this integral as x to the fourth plus 2 plus x to the negative 4. So now you can just simply integrate this without u substitution. Raise it by 1, put it over the power. The answer then can be just simply written as 1/5 x to the fifth plus 2x minus 1/3 over x cubed plus c. Alright, on the next problem, we will go back to making a u statement for this one. This one's also a definite integral, so we'll need to change the bounds. I only need the dx, so I'm going to move this over, and that gives me negative 1/2 du. Remember, we're going to rewrite this in terms of u, so we want to change our bounds in terms of u. So you plug 0 in for x. 1 minus 0 is 1. plug negative 2 in for x, and you get 1 minus 2 times negative 2, which would be 1 plus 4, which is 5. So then we'll rewrite this as u to the negative 1/2. That takes care of this portion. Only need the dx, so I need a negative 1/2 out front with a du. When I integrate this, I just bring down my negative 1/2, erase this by 1 and put it over 1/2, which is putting a 2 over 1 out front. And then I'll be evaluating this from 1 to 5. You can go ahead and multiply these together first, which does just give you negative u to the 1/2. So my answer, plug in the 5 first, I get negative square root of 5, minus, plug in the 1, the square root of 1 is 1, negative 1. So my answer becomes negative square root of 5 plus 1. The last one for this day, day 2, says using graphing a calculator or graphing utility to find the area in the first quadrant bounded by the x-axis, x to the third, and x equals 3 and x to the third. I've gone ahead and graphed that in the graphing calculator already. Notice how this only goes out to 1 right now. I really want to look way over here to 3. The area bounded in the first region then would be anything underneath the curve all the way over here to 3, and that would go clear up to 27, and I'm not going to graph that far, but it's the area underneath that curve. I do want you to practice with your particular graphing calculator. On this one, I simply just type in 0 to 3, because that was my bounds from 0 to 3 in the first quadrant, x to the third, and I just hit enter, and he evaluates for me, and you should get 81 over 4 or 20.25. Make sure that you can use your graphing calculator. Yes, this one could be computed by hand as well for this particular problem, but we have to make sure we can use our graphing calculator as well. Alright, now we're on day 3. On day 3, we've got some of the trig functions in there. When we make our u statement, we're going to make our u be 4x. The du would be 4 dx. When I go to rewrite this, I'm going to rewrite it as sine of u. Problem is, I still have the dx, so that's why I need the 1/4 du for my dx. So I'll write 1/4 du. Integration of sine is negative cosine of u, and so my answer ends up being negative 1/4 cosine 4x plus c. In the next problem, I've got 2 trig functions, unlike the first one. When I have 2 trig functions, typically I have to pick one of them to be my u. I'm going to pick sine of 4x to be my u, because when I take the derivative of sine, I will get cosine. So the derivative of sine is cosine of 4x, but you have to remember to take the derivative of 4x as well, which puts a 4 out front. When you go to rewrite this, you get u squared. That takes care of your u. You just want cosine 4x dx, so we'll bring the 1/4 over. And I'll put a 1/4 du on here. 1/4 u to the third over 3 plus c. This gives me 1/12 u cubed plus c. U, remember, is sine of 4x. This can also be rewritten as 1/12 sine cubed 4x plus c. Either one is fine. The last one for day 3 would make, I would want my u to be secant x. The reason for that is because the derivative of secant x is secant x tangent x. So when I rewrite this, it ends up being u to the negative first, or negative 1/2, excuse me. I need secant x tangent x dx. I have exactly that by putting a du. When I integrate, I get u to the 1/2 over 1/2 plus c. Typically I've just been putting that reciprocal out front. I didn't on this one. So my answer ends up being 2 square root of u plus c. Now your u was secant x. This is the final answer. Starting day 4. On day 4, I only have one trig function again. That leads me to believe that I just want my u to be x cubed, whatever follows that trig. So I get 3x squared dx. When I rewrite this, I get u, excuse me, erase that. When I rewrite it, I actually get cotangent squared u. That's this part. I need x squared dx. I have that by putting in a 1/3 du. So I'll write 1/3 du. The integral of cotangent squared is negative cosecant u plus c. So my final answer would be negative 1/3 cosecant x cubed plus c. For my next one, I have one trig function that leads me to believe that I want to pick what follows it. That's an x to the negative first. So my du would be negative x to the negative second. So du ends up being negative 1 over x squared dx. When I rewrite this, I get sine of u. That's this part. I need 1 over x squared dx. I have that. If I just put a negative du, the integral of sine is negative cosine of u. So that gives me a positive cosine u plus c. U again was x to the negative first, or 1 over x. Last one of these practices for your u substitution quiz looks like this. U is x plus 1. Notice how my derivative only gives me a dx. There's no way to get that x. So this is one of those special ones where we go to rewrite it. U to the 4. I need an x dx. Well, I only have the dx by putting a du. So I took care of that, but I still have this x to take care of. So that's when you have to solve for x, and so x is equal to u plus 1. So we'll put a u plus 1 here, and now we'll have to rewrite it. Since it's a single term on the bottom, u over u to the 4th is u to the negative 3rd plus u to the negative 4th. And now I can integrate it because it's a term plus a term. So this is going to give me u to the negative 2nd over negative 2 plus u to the negative 3rd over negative 3 plus c. I get negative 1/2. This is on the bottom. U squared plus or minus minus 3u cubed plus c. There'd be a 1 on top there. Now your u was actually equal to x minus 1, so I just need to put those in there. X minus 1, oops, I forgot my little squared there. So that gives me negative 1/2 u to the 2nd minus negative 1/3 u to the 3rd plus c. If you know these problems for your quiz, you should do rather well.